All right. So to show that binomial is a factor, we use synthetic division, right? What do we put in the corner again, Ryan? You said 2, right? You guys understand that, right? If the binomial is x minus 2, we put 2 in the corner. All right. So then I put 6 for the x cubed, 8 for the x squared, negative 34 for the x, and then the negative 12. We didn't have to add any zeros. 2 times 6 is 12. When I add, I get 20. 2 times 20 is 40. When I add, I get 6. 2 times 6 is 12. When I add, I get 0. That's what's supposed to happen, right? We just showed that x minus 2 is a factor of 6x cubed plus 8x squared minus 34x minus 12, okay? So this here, what's left is 6x squared plus 20x plus 6. All right, we're supposed to factor that part. Is there a GCF? 2, right? So take the 2 out. So x minus 2 is still part of it. Then I get 3x squared plus 10x plus 3. Since a is not 1, what do I have to do with a and c? Multiply them, right? That's the rule. When we factor these trinomials, and a is bigger than 1, right? So we look at factors of 9 because we went 3 times 3 to get the 9 that add up to 10, which is real easy, 1 and 9, right? So I have to rewrite that problem. 3x squared plus 1x plus 9x plus 3. We split the 10x into those two factors, 1 and 9x. Okay? And then I group it. So remember, we usually group by doing the first 2, last 2. So that's what I'm going to do. X is common to the first group, and 3 is common to the second group. 3x squared divided by x is 3x, and 1x divided by x is 1. And 9x divided by 3 is 3x, and 3 divided by 3 is 1. Is it working out like we want? Yeah. All right, so our final answer, if I have a GCF, I like to pull that out front. But again, it doesn't matter where you put it. Just make sure it's in your answer. It's part of our factors. Then the x minus 2, and then the 3x plus 1, and then the x plus 3. And again, it doesn't matter what order you have those factors, but those are all the factors of that polynomial, that function. Okay. So that was number 16 on the worksheet. We didn't have to do that. We just did the odds, right? So number 1 for your worksheet was 20x times x minus 5 times x minus 6. Number 3 was a sum of cubes. The cube root of both of those was 3a plus 2b, the binomial part. And the trinomial part is 9a squared minus 6ab plus 4b squared. That's those two. Need me to do either one of those? Again, I'm just taking the cube root of both of those. Those are both perfect cubes. Cube root of 27 is 3. Cube root of a cubed is a. If it's plus, that's plus. Cube root of 8 is 2. Cube root of b cubed is b. All right, so I just took cube root of those two terms. Now I take the 3a and I square it to get the 9a squared, the first term of the trinomial. Since that's plus in my binomial, my middle term is always opposite, so this one's minus. I multiply 3a times 2b to get the middle term. That's 6ab. The third term of these trinomials is always plus when we do this method. And I take the 2b and square it, which is 4b squared. That's the answer. Okay? Let me just go through these real quick. Factors of 48 that add up to negative 13 are negative 16 and negative 3. No, positive 3, sorry. Negative 16 times 3 is negative 48, and negative 16 plus 3 is negative 13. This isn't finished because this first binomial here is a difference of squares. So that's y squared minus, or y minus 4, y plus 4 for that difference of squares. Okay. Number 7, 10 is common. So when I take out the 10, I get this, which is a difference of squares. So square root of 81k to the 4th is 9k squared. Square root of 16 is 4. One's addition, one's subtraction. But I'm not done, because this subtraction one is another difference of squares. So I got my 10, my 9k squared plus 4. I can't go any further when it's addition, when they're perfect squares. But when it's subtraction, square root of 9k squared is 3k. Square root of 4 is 2, plus and minus. Simple. All right. Number 9, 2x to the 4th is my GCF. Dividing 2x to the 4th into each term, and I get that. Well, that trinomial is easy because a is 1. The factors of negative 21 that add up to negative 4 are a negative 7 and a positive 3. Number 11, 2 is common. It's 6x squared minus 11x minus 10. Since a isn't 1, 6 times negative 10 is negative 60. Negative 15 times a positive 4 is negative 60. And negative 15 plus 4 is negative 11. So I rewrite it as 6x squared minus 15x plus 4x minus 10 and group. 3x is common to that group, and I get 2x minus 5, sorry. 15 divided by 3 is 5. 2 is common to this, and I get 2x minus 5 again, which is what I wanted to show up, right? Those two binomials to be the same. So remember, 2 is part of my answer. Then I got 2x minus 5, and then the 3x plus 2. All right, number 13, GCF is x. Get 4x squared minus 4x plus 1. Some of you weren't putting the 1. If there's 3 terms to start out, there better be 3 terms in your parentheses when you factor out a GCF. Again, let's see here. Those are both positive perfect squares, so I believe the 1, 2, 3 test may work. Let's check it, because those are both positive perfect squares. The square root of that is 2x. The square root of that is 1. Multiply those together is 2x half of 4x. Yeah. So, x. What I got for number 1 goes in the front. What I got for number 2 goes in the back. Whatever the sign of the b value is, and you square it. So those are the odd ones you were supposed to do. Okay? 15, just like the warm-up, 1 for x cubed, 0 for x squared, negative 13 for x, negative 12. What number am I supposed to get for my remainder? 0, thank you. Negative 1 times 1 is negative 1. Add those. Negative 1 times negative 1 is positive 1. Add these. Negative 1 times negative 12 is positive 12. I get 0. That's what I want to happen, right? So remember, this is x plus 1. That was x cubed, so this is an x squared minus x minus 12, which is an easy one. The only way to get x squared is x times x. What factors of negative 12 add up to negative 1? Negative 4, positive 3, right? There's our factor completely finished. 17, the last one. Put 5 in here. 2, negative 12, 6, 20. You got to add the 0 on the end for your constant. 5 times 2 is 10. 5 times negative 2 is negative 10. 5 times negative 4 is negative 20. That's 0. 5 times 0 is 0. Got 0, right? So it worked out like it's supposed to. So this is x minus 5. And that was 2x to the 4th to start. So this is 2x to the 3rd minus 2x squared minus 4x. Don't have to worry about the zeros. What's the GCF of that? Thanks, you guys. 2x. 2x cubed divided by 2x is 1x squared. Negative 2x squared divided by 2x is negative 1x. Negative 4x divided by negative 4x divided by positive 2x is negative 2. Factors of negative 2. I should have put 2x out front, but that's okay. Factors of negative 2 that add up to negative 1 are negative 2 and a positive 1. Done. Simple. You can do it. Easy. Questions? Berkeley, you got a question? Okay. You're going to have to be able to factor to do what we're doing today, tomorrow. Okay? So here we go. Finding solutions and zeros to higher degree polynomial equations. That's what we're doing. Okay, so we've solved quadratic equations. Where we just had x squared, right? Where we factored. Okay, we're going to do the same thing. We're going to factor. And then once we get it equal to, get it factored, then we're going to set each factor equal to 0 to finish up, just like we did for the quadratics. So the GCF here is 2x, and I get 2x squared. No, I don't. 2 divided by 2 is 1, right? So I get x squared minus 6x plus 9. All right? This is one of those special trinomials, but you guys probably realize it's just going to be x minus 3 times x minus 3. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6, right? But you could write it as 2x and then x minus 3 to the second power because they're the same. All right, once we get to here, we set each factor equal to 0. So you write 2x equals 0, x minus 3 equals 0, and you really don't have to do it twice, but I'm going to. Divide by 2 to get x by itself. 0 divided by 2 is 0. Add 3. X equals 3. So there's our 3 answers. Look at our degree. The degree is 3. That's how many answers or zeros you should get. Okay? Sometimes a 0 works more than once, like this. 3 worked twice this time. We call that multiplicity. Okay? That's a multiplicity of 2, or an even multiplicity. That means it just works more than once. Okay? So just factoring, set your factors equal to 0, solve your little equations that you have. Those are your zeros, your solutions, your roots. Depending on how the problem's written, they ask for roots sometimes they ask for zeros, sometimes they just ask for the solution. Okay, they all mean the same thing. All right. Again, same type of deal. Factor. Okay. So my GCF, greatest common factor, is 5x. So I get 1x squared minus 8x plus 16. And that's one of those special trinomials. We could do the 1, 2, 3 test. But I'm just going to go x minus 4 and x minus 4. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. So it's very similar to the last problem. I set each of those factors equal to 0. 0 divided by 5 is 0. So there's one of my solutions, one of my roots, one of my zeros. And since there's both the same, we won't do it twice. Oops, why did I write 2? I was thinking it worked twice. So we could put 2 times next to it, meaning it works twice. It has even multiplicity. When we graph it, and the next slide is going to tell us this. When we graph it and it has even multiplicity, excuse me, I've got something in my throat here. When you look at the graph, it will hit, like if it's coming from the bottom, it'll hit at 4 and then bounce off, go right back down. It won't go through, right? If it's coming down, it'll hit at the 4 and then bounce off and go back up. So if a 0 has even multiplicity, the graph will bounce off of that number, off the x-axis. Those numbers is where the graph crosses or touches the x-axis, the zeros. Okay, and that's when y equals 0, right? When you're on the x-axis, that's when y equals 0. All right, so that's what this is saying. In example 1, the factor x minus 3 appears more than once. This creates a repeated solution of x equals 3. See, we got 2 3s. That's what it's saying. All right. Note that the graph of the related function touches the x-axis but does not cross the x-axis. At the repeated 0, x equals 3, and crosses the x-axis at 0 equals, or at 0, x equals 0. This concept can be generalized for the polynomial function of when a factor x minus k or x minus 3 of f of x is raised to an odd power, the graph of f crosses at that spot. When a factor raised to an even power, it touches but does not cross. I say bounces. Bounces off the x-axis, all right? So if we go back to, there we go. If we go back to that example, we'll see the graph bounce off at 3. Let's go back to that and put that in our calculator. So another way that we can figure these zeros out, okay, is put it in our calculator. X caret 3 for x to the third minus 13 x minus 12. Oh, that's not the one I wanted. I went far, too far. Sorry about that. Here it was. All right, I want that one. 2x to the third minus 12x squared plus 18x. All right, so I hit graph. Remember, it's going to go through at 0 because that's an odd. It only worked once. Right? Whenever it's odd multiplicity, only works 1 time or maybe 3 times or 5 times, depending how big our degree is. All right, it goes straight through at 0. And then at 3, since it worked twice, it's going to bounce off at 3. And it went through the 0 and then it bounced off at 3. make this a little bigger. It's kind of hard to see it go through 0. But came up, there it is. Came up here, went through 0, and then here at 3, it bounced off. That's 3. Right there is 0. Those are the 2 zeros we just figured out by factoring. Okay, but the graph will show you the zeros also. Okay. So when we get to those ones that really are tough to factor, all right, we can factor this, but if you want to get started doing it this way, putting it in your y equals, that's fine with me. So I hit clear. Negatives down here. 2x to the 4th plus 16x squared minus 32. That's one we could factor, but we'll just go ahead and graph it and look. See what happens. Looks like an M. Okay. So what that's telling us at -2 and +2, and again, you can go to your table, second graph, the table, wherever the y is 0, right there, that's one of our zeros, and we know 2 is the other one. All right, so you can look at the table to make sure that those are the correct numbers we thought. Okay, so whenever y is 0, that's the zeros of the problem. That's what we're looking for. Okay, this number, what did we say this number told us on the quadratics? That was the y-intercept, right? So this graph, if I sketched it at, we'll just say that's -2 and that's +2. And we'll just say this at the very bottom is -32. So this is what it looks like. Okay, that's a quick sketch of it. So you can do it without factoring. But if it says you should solve by factoring, you should. All right, so this one we'll solve by factoring. Pull out the x. X squared plus x minus 6 would be x plus 3 and x minus 2. 3 times -2 is -6. 3 plus -2 is 1, right? So set your factors equal to 0. There's one of them. You guys are from quadratics, know we did that, right? So I have a 0 here, a 0 here, and a 0 here. Okay? None of them work more than once, so there won't be any bouncing. It's just probably going to go like this. It's probably going to go up through the 3, turn around, come down through the 0, and then turn around and go back up. Or it might come down through the 3, up through the 0, back down through the 2. And we can just go ahead and use our calculator to look at the graph. All right, clear it out. X cubed plus x squared minus 6x. There it went up, down, up. Okay. So I thought I got rid of that. So, we sketch it, goes up. Oops. Gotta go back to my pen, sorry. Now it's going to go up, down, and up. Okay. So the zeros are where the graph touches the x-axis. You got me? Simple, right? You can do it factoring. I always like to factor if I can factor. We get some tougher ones, something like that. That's going to be hard to factor. We get something like that. Let's put in our graphing calculator and see where it crosses, right? Now, there was a thing back in the day when I was at Lake High School, we had to use this rational root theorem, okay? We didn't have a graphing calculator. So just to tell you what I had to do, we look at all the factors of 64 and all the factors of negative 105, all right? And the factors of 64 would be the numerators, and all the factors of negative 105 would be the denominators, okay? And we'd write all of these fractions out. And then we'd have to use synthetic division and see where I would get a 0 for the remainder, telling me that that would be a factor of the polynomial, right? And then I could simplify down and try to factor it, okay? You don't have to do that, all right? So we're really not going to use the rational root there. We're going to put this big, huge looking polynomial in our calculator and look to see where it hits the x-axis on our graph, okay? And that's how we're going to get our zeros. So it's a lot easier for you guys because of the graphing calculator, okay? So we're going to put that in our calculator. Again, all the real solutions. Okay, sometimes there will be non-real solutions. You know, the i's will start popping up again. Square root of negative 1. But right now, we're just worried about the real solution. So x cubed minus 8x squared plus 11x plus 20. So it looks to me like that's negative 1, it looks like to me. 1, 2, 3. That looks like a 4. And that looks like a 5. Okay. I'm going to go to my table to make sure if it'll ever show up again. There it goes. Second graph is my table. Negative 1, I was correct. There's that one. Let's go down and see if 4 and 5 are zeros for the y. There it is. Yeah. Okay. So how many solutions am I expecting? 3. Did it show me all 3? Yeah. Okay. So I'm good. All right. Put that in your calculator quick and see what you get, please, just for practice. Quick. Only one. Only should be one. Look at the graph. Correct. Yeah, 2 negatives. So go back to your table. Second graph. There you go. Now go up. Where's the others? So this is what it should have looked like in your calculator. Make it a little bigger for you. So there's 3 spots it crossed. It looks like -3, -2, and 4. Is that what you guys got? There's 3 spots it crossed. And I had a degree of 3. Okay, if I go to my table, there's the 4. So it's right there. There's a -2. There's a -3. Okay, so that was right. I always check on my table just to make sure. Okay? So, factor what you can factor. When they get tougher to factor, use your calculator. There's your assignment. Thanks for participating.